Greetings and welcome to the video introduction to the qualitative analysis of Group 3 cations lab for Chemistry 223. And you could once again probably see why I call this QAIII a lot more than I do that long name. QAIII is very similar to QAII. It's the same kind of non-math, more experimental-based observations. Your safety is really important to me, so please try and be safe. But I think you'll enjoy QAIII as well, especially if you like QAII, that is. So let's talk about QAIII and see what kind of things it has to offer. QAIII, qualitative analysis of group 3 cations, is very similar to QAII, qualitative analysis of group 1 cations. And again, historically what they did is they separated out different metals into these groups. So QAII was silver plus, lead 2 plus, mercury 2 plus. Group 3 cations is chromium 3 plus, aluminum 3 plus, iron 3 plus, and nickel 2 plus. And they all had similar patterns of reactivity that they used. Anyway, yes, there is a group 2 cations and there's a group 4 cations. There's some group anion that are around and stuff as well. So again, historically, these were kind of important when they didn't have technology to figure out what metals were there. These were kind of cool chemical techniques to see what's happening. So again, what we'll do in this lab is we'll start with a mixture of all 4 of them, at least with a known. You'll then separate chromium and aluminum from the iron and nickel. And from there, then you can separate the 2 ions, one from each other, and finally then confirm that they're actually there. So it's kind of a cool lab. So in this lab, like I said, first you're going to separate the nickel and the iron from the aluminum and chromium. Hydroxide, by the way, is a great way to do it. So sodium hydroxide would be a source of it. And then what you're going to do is isolate each of the ions and confirm its presence, very similar to what we did in QAII. The differences between QAII and QAIII, though, is that obviously you have different metal cations, so it's going to be different reactivities. Now, once again, you'll be graded on the accuracy, like which ones are inside. So there's a thing to circle yes or no. Pretty hard math there, i.e. no math. And also, just as an FYI, the color of the metal cations can be very helpful. And I'll talk about this here in just a little bit. Similar to QAII, there'll be some techniques which are also very useful. Centrifuge, which you probably did in QAII, will be neat. You'll put 2 centrifuge tubes in a centrifuge, put them opposite each other. So like 12 o'clock and 6 o'clock, left and right, so they kind of balance each other. And as it spins, then the solids will go towards the bottom. And again, about a minute is all you need to put in the centrifuge, not too long. Decanting, which means getting the liquid supernatant away from the solid, is also an important technique. It's a faster way than filtration. And decanting means you're going to get most of it separated, so if a little bit is left on either side, it's not the end of the world. Heating will be important. Now, heating in QAIII can be a little different. Some of the volumes are so intense that it's better usually to put your solution in a small beaker, like a 30 milliliter beaker, and place the beaker directly on the hot plate. But you must watch your solutions, because if you overheat, it'll cook it and you'll end up then with a solid. And solids, once I kind of break through all of our instructions here. So just watch it very carefully. All right, don't let it overheat. You can add a little extra water if you need to, and sometimes that can be really important. So just watch your samples, especially when they're on the hot plate, because they will burn really fast and stuff, and then you have problems. We'll also use pH paper to confirm the acidity or basicity of our solution. Put little pieces of the pH paper on a watch glass, like cut those little rectangular pieces into 4 or 5 pieces, and then using a stirring rod, you can dip it into your solution and then dip it onto the piece of pH paper, and the color will tell you that. So the red and oranges are acidic, blue and greens are basic, etc., etc. Like before with the QAII lab, you want to analyze your known sample and unknown sample at the same time. So you'll make your known sample. It'll have about 6 drops of each of those 4 ions in a tube, and the other one will be your unknown. All right. And like before, the known will always have a positive result. The unknown may or may not have a positive result. You definitely want to be safe in this lab. You want to wear safety goggles all the time. Don't have open-toed shoes. Don't wear shorts. Don't have any any exposed stomach kind of shirts on, because that's bad. I really want you to be safe, all right? So I'm being a little extra careful here. Another difference, though, in QA3 versus QA1 is that 3 of the 4 metal cations actually have a color to them, and I encourage you to look at the bulk bottle. You're going to look for these. Chromium's kind of a blue color, the nickel's kind of a green color, and the iron is kind of a very subtle yellow color. Aluminum doesn't have a color, so aluminum will be the hardest one to identify. But before you even start any of your chemical tests, just looking at your unknown, you can make predictions as to what it is. If it looks blue, you've got chromium. If it looks green with no blue, then you've got nickel. If you see kind of a yellowish color, then that means iron. Aluminum, again, will be the one that's hard to do because it's colorless, all right? So just be aware of that. But, to be totally honest, you can always just guess aluminum, 50-50 chance, yes or no. It's better to go through the test, but you get the idea. Iron and nickel are relatively easy and fast to identify, all right? At the very beginning, you'll separate them from the aluminum and the chromium, and the tests for iron and nickel go pretty quickly, you'll see. But the chromium and aluminum can be kind of tougher. So again, remember that chromium is always kind of a blue color. So if your unknown has a blue color, you will have chromium. You should have chromium. The aluminum, though, is difficult because it's colorless and it can be kind of challenging. Put all the waste in the waste jar. You'll include a flow chart like before. And again, the flow chart will show how you separate the 4 ions, first of all, from each other, and then have a confirmation yes and no kind of part with it. Should be pretty chill. You can make the flow chart by hand, or you can do it on the computer. Try to have fun with this lab. Okay, about this time, I think it's time to watch a little introduction video that shows what the lab will be like. If you have questions on this or anything else, definitely let me know. I'm happy to help. All right, let's watch a video.